Okay, then. Then you guys should use me to maximum effect. What stages are you guys? Chioma, what stage are you?
So I'm still in stage 1.
Yeah, it's not a sickness.
I'm sorry.
But why are you still in stage? Are you stuck on a task or?
Yeah, I just started because we were having light issues in my
Oh,
area for like 1 week. So I'm sorry.
then it's not a problem. It's not as if you were stuck on something.
Yeah,
Okay,
I just like started
okay.
stage 1.
Then it makes sense. Then it's not sickness, so don't worry. You will live there, don't worry.
Okay.
It's like this thing people used to say, God win. Don't worry. Very soon.
Mm.
Just finish it. You know God, you know when God will move you out of stage one. Real one,
Very-
stage are you? Real one? Can't hear him. I think he's trying to talk, but we can't hear him. Or can you guys hear him?
Yes, I can hear you.
You can hear real one?
No, no, no. I
Okay.
can't hear him, but I can hear you.
Okay, cool. Miriam. Miriam is ghosting me. Odunayo and Kanitat. I'm not sure I pronounced that right. Kanitat.
Hi, good evening, sir.
Good afternoon. Did I pronounce it well?
Yes, contact.
Konitat. Okay. Yeah. So how are you? What stage are you currently?
I'm on stage 2.
Oh, cool. Cool.
I'm here to start the models, but I'm
Okay.
on stage 2 currently.
Okay. Okay. Um, so should we go over the tasks together? Or I mean, I believe you guys have already um
I scanned through and it was looking bulky. Like I was going to go back to it.
okay. Yeah, but I don't think it's just playing with data, right? Think about it as playing with data. Don't think
Okay.
about it as a
Hello, sir.
hello.
Good afternoon, sir. I was not ignoring you. I was busy doing something.
Things that are better than listening to us. Cool.
No, 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 no.
I'm just kidding. I'm just whining you. Don't worry. Um, yeah. So what stage are you currently?
I'm in stage 2.
Cool. Um,
Yes, sir.
um, so that means you are happy so far?
Sir?
You are happy so far?
I hope I'm happy. I'm still battling with the because there are some things in stage 2 that I'm still trying to like understand some functions there
Okay.
that I still don't understand. So I'm trying to like go through everything and get to know it better and
Oh,
get myself familiar with it.
yeah, but if you are stuck or if something is unclear, you can always ask me.
Yes, sir.
I think someone requested for something from me this afternoon, and it was just the person just needed comma. That's all. Like the person just needs to put a comma, and I figured it out for the person, and the person got the solution immediately. So yeah, if you are stuck on something, it might just be something very tiny, and it doesn't really mean you don't know it. It's just you are not yet familiar with the language, right? And the computer is not understanding you. That's all. It's not. It's not. It's not a bad thing. It's not a bad thing. Okay. Okay. I'll try to go over some of the tasks because I think it's a lot of tasks. It's just you just have to think about how you want to play with the data. That's all. And really one that has been requesting for a call, unfortunately, is unable to ask questions. If you can type your question, because battling with stage 2 is not a There's no way I can help with that. If you can type your questions, maybe I could help. So I will try to go over some of the tasks now in stage 2. Okay, so let me share my screen. I hope you can see my screen. Yeah. So the first one is microbiology. And the task says to look at the data sets. You look at it. Let me look at it so that I can have an idea. Okay. We have growth curve data there. And the description of the data set is also there. Now, plot all the growth curves in, hold on, plot all the growth curves of OD 600, yeah, versus time. Do you guys know what is called OD? Miriam, your chairman, do you know what is called OD? Conitats.
No, sir.
Okay, yeah, optical density. Although I said optical density. So if you remember from the last time, we were talking about logistic growth curve. So in bacteria, on this side, you can have things like CFU or colony forming unit. So basically, what you're having here is, if you remember from the last stage, it's called population size. Population size. Now, in bacteria, the way to actually count population size could be optical density. Basically, that's the turbidity of the culture. So that's still, I think that's a lot of microbiology for you guys. Maybe I should also ask, which of the data sets do you think is most interesting to you so that I don't bug you with what is probably not relevant for you guys? Which of the data sets? Is it microbiology? Is it botany and plant science? Is it biochemistry and oncology with a lot of proteins? Is it transcriptomics? Is it public health? Which one, guys? Nobody's talking.
Like I said, I haven't really gone through it, but first impression, I think I'll be cool with public health. But I skipped micro and botany part.
Okay.
I focused on public health for a while, so I said I was
Okay.
going to come back to it.
Okay. Okay. Yeah. Then I can go over to public health after this. But yeah, in principle, if you remember from last year, we were dealing with optical population size against time. So the data in this stage is actually real data from population size, and it's actually real data showing logistic growth curve. If you plot any of the data, any of the curves in that data set, this is what you're going to get. You're going to get something similar to this. It's actually bacteria growing over time, right? Now, what we ask you to do is first to just plot it, just plot, right? Now, the next thing is that for each strain, plot a growth curve of the knockout and the knock-in strain overlaid on top of each other. I'll look at the description of the data set now. So the point we are trying to make here is that we just want you to plot the we just want you to plot the knockout and the knock-in. The knockout would be the knockout will be the mutant, and the knock-in will be the I think it's too abstract for. Hold on, I'll just bring the yeah. Can you guys see my screen now? I need someone who can be responding, please. You
Yes,
know
we
what
can.
that to do with. Okay. So we said we want you to plot the mutant and the wild type in the question. But here, here you should just, sorry, we said knock-in and knockout. The knock-in would be the wild type in your case. I would write this again. The knock-in, that's the positive. Would be the wild type, just for this scenario. And the knockout will be the mutant. So we just wanted to plot them on top of each other, right? So you have one growth curve, you have another growth curve on top. Maybe the knockout will be yellow and the knock-in will be the red, something like this. Does it make sense? It's just a simple visualization test. It's nothing complex. I don't know if you guys get me. Hello? Everybody is so quiet. If you don't get it, you can also ask me. Okay, looks like you can't hear me. Okay. Okay, so really one says he understands. Hopefully you understand as well. So basically what we expect is that if you want to plot strain 1 alone, right? You pick mutant from strain 1, mutant from strain 1, and mutant from, I don't know if I'm selecting it right anyways. Basically, you have to also show this in a table in a way. But basically, I selected the mutants A1, B1, sorry, these are the wild type. A1, B1, and C1, they are the wild type. Hold on, I'll just clean everything up. Just clean everything up and then plot again. So I have my growth curve and I want to plot the wild type. So the wild types, let's say our wild types are yellow, A1, B1, C1. And then to plot them, I have 1, 2, 3. Let's just say they overlap and they're very similar. But then for the wild type, I now have, which is A2, B2, and C2. So you have 1, 2, I don't know if this is how it looks like, and 3. And then on this axis, you have the OD, and on this axis, you have the time. This is exactly what we wanted to plot. I saw a question just now. The knocked in, I didn't really get. I agree knocked out has been mutated. Yes. Who is that? Yes, so for this situation, the white type, the knock-in does not exactly mean white type, okay? But for this case, just let's use our knock-in. It's a missed, I can correct it also here. I can correct it. What we mean is that we just want you to plot the knock-in against the knockout, assuming the knockout is your white type. Assuming the knock-in is your white type. It's not so much about the, how do I call it? It's not so much about the biological meaning behind it. Yeah, it's not so much about the biological meaning. Okay, hopefully that was clear. So another question again. Okay, good. So using your function from the last stage, determine the time to reach the carrying capacity. So you should also determine, oops. So this is like a test for your last stage, if your function worked, because this is the thing in coding generally. When you write software, it has to be usable, not just by you, but by others. And it also has even to be usable by you for several applications. Okay. It has to be usable by you for several applications. Give me a minute. Okay, sorry. It's just a couple of messages that came just now. Hold on. The cost of interesting. Okay. Yeah, I got it. I got some tickets to attend the robotics conferences. It's just and they give it for free. Unfortunately, it's in Munich in Germany. I don't know if anybody can come. So when you generate the carrying capacity, that's the 80% of your OD, basically. When you know the 80% of it, so you should generate a box plot that collates all the knockouts and all the knocking together. I don't know if you get my point. So from all the curves that you plotted, let me draw the plots again. So let's say you have your knock out, and then the knocking. So let's say you have all of them, and then you collected 80% somewhere around here, 80%. And let's say you want to know the time, so you determine the time. So the time it takes to reach this place, that is, you know the x-axis, you know the 80% from the y-axis, and then you use it to trace the x-axis. So let's say you have here it is 3 hours, here it is 4, and here it is 4 hours. So 3, 4, and 4. Here you have, let's say 7, 8, 9. So we expect you to now do a test, a statistical test, to compare this population against this population. Are they different, right? Does anybody understand that, or is it too complex? So, anybody confused? If you're confused, let me know. Okay, someone understands. I will assume everybody understands if nobody's complaining. Chioma, do you understand?
Yes, sir.
Okay. Konitat, do you understand? Konitat, okay, she's away. Miriam, maybe Miriam is also not here. She's Odrayo.
Yes, sir, I understand.
Perfect. Okay, I think everybody understands then. Okay, somebody doesn't understand. Okay, I think everybody understands. So let's quickly talk about task 2.3. So botany and plant science. It's basically the same thing as well. To compare mutants against wild type, and then you are supposed to find a cutoff of your choice, calculated as the difference between the fitted line. No. So basically, you're also finding difference between the wild type and the mutants. I won't go over this so much because it's literally the same thing as well. So you have to look for things. Yeah, you have to look for outliers in this case. You have to look for outliers in this case from either mutants or wild type, and then plot them against each other. And then, are you going to supposed to do any statistical? Okay, there's no statistical test. I think the detection of outliers is already a very tough statistical problem. So, yeah, that's the main issue there. But if you have any issues, remember to ask me. Let me quickly go over to the public health because someone requested for it. So this is a public health data set by the CDC to assess the nutritional status of adults and children in the United States. It combines survey questions and physical exams, including medical, physiological measurements and laboratory tests and da 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 da. The data is used to determine the prevalence of disease and risk factors, da da da. This information helps to develop public health policy, da 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 da. Good. So take a look at the data sets and take a look at the data dictionary. I would prefer to go over the data dictionary because it's easier to explain the entire data set just from the dictionary. So you have the ID of the sample or of the patient, you have the gender, you have the age. I don't have to explain all of that. You have the race, you have the education, you have the marital status, you have the relationship status, you have the insured, whether the person is covered by health insurance, you have the income of the person, you have the poverty level of the person, you have how many rooms are in the person's house. So it counts kitchen, but not bathroom. Home own, whether the person owns a home, is renting an apartment, and other things. The work, actually, it's a lot, so I'm not going to go over everything. Basically, these are some of the things. But in this case, the goal of this data set in this case is to study obesity, the prevalence of obesity, and what's this thing called? Obesity and type 2 diabetes. So the first thing you have to do is to process all NS. There is usually a debate I'm expecting to come up around this stage, so looking forward. So when you process all NS, you would observe something. So let's know what you observe. Visualize the distribution of BMI. You guys know BMI by now, body mass index. NA means, oh, sorry, NA means not available. That is, the number is not available. It's not existing. It's they did not record anything for that patient on that specific value. For example, maybe they were unable to get the patient's age, or maybe they were able to get the patient's the age where the patient started first reported diabetes. Okay, yeah. So something like this. It's so visualize the distribution of these with an histogram. Yeah, so visualize BMI. Was BMI included? Okay, BMI was included. I would have said you guys should have calculated it. Then weight and all that. Then what is the mean 60 seconds pulse rate for all the participants in the data? What's the range of value for diastolic blood pressure in all participants? That's the range of values for diastolic blood pressure. I don't know, people in physiology will probably understand what that means. I think it's one of the, so if you measure blood pressure, there is one that is on top. There's one that is, I think one is systolic and one is diastolic. I'm not a physiologist. I'm not a physician. Then what's the variance and standard deviation for income amongst all participants? You should also calculate this. Visualize the relationship between weight and height. And especially, especially you want to know the relationship between the weight and height across gender, across people with diabetes, and across smoking status. So choose any visualization method you want. So it's just, how do I say, epidemiological reporting for patients, for people in general. And then finally, conduct a t-test for these kind of things. For this, so you have to conduct a t-test on the relationship between them based on the p-value, that is the age and the gender of the patients, based on their BMI, and so if you have, hold on. Yeah, yeah. So if you have, so you are comparing, let me think about this. I can't remember exactly we planned this anymore. Conduct tests between variables and make conclusion. Yeah, so basically you want to know the influence of age. No, hold on. Let me think about this. Yeah, so you want to understand the influence. No, not the influence in this case, but you just want to understand the relationship between age and gender. So if you plot all of the male and all of the female, which of them is older? And you have to show that statistically. That is just from this data set. If most male are centered, or the mean age of most male is 50 and the mean age of most female is 50, is there difference between the two of them? So you should check that. If one is higher than the other, you should also use a statistical test. You should also think about the right statistical test to use. But I think for most of the tasks we have here, you can use, okay, we already mentioned it. A t-test would do. Sorry, I didn't see it. Then BMI and diabetes. What's the BMI of people with diabetes and the BMI of people without diabetes? What's the year of alcohol usage? I think it's the number of years of alcohol usage. Let me check. Alcohol, yeah. Yeah, estimated number of days over the past year that the participants drank alcoholic beverage. That is, if the person has been drinking alcohol for 50 years, what's their relationship status? Do people that are in relationships have a longer duration of drinking alcohol versus those that are not? This data would also tell you. Okay. I think every other thing, like the transcriptomics and protein biochemistry, they are also straightforward. It's just wrangling the data and in the end, generating some statistical analysis to differentiate the mean between the two samples. I don't know if it looks like I've been talking to myself alone. Yeah, it's because I'm not seeing you guys. But does it make sense to you guys? Okay. At least somebody is following. I'm happy. You guys can listen to the recording, and if you have any other questions, you can ask. Good. The blessing is also following. Okay. I'll wait for 5 more minutes. Should we have any questions, you can drop it. Okay, drop your question. I mean, I actually prefer answering questions than explaining or talking or teaching in principle. I'm waiting for your question because we can't hear you. We didn't hear you. I saw that you're on mute, but we didn't hear you. probably drop a text chat. I think it's a problem with your microphone. Okay. Firstly, on importing data. Why should I give an example? I'm not with my... So it depends on the programming language you're using. Importing data is relatively simple. You should go over the course. It's okay. Importing data. I find that strange. So the problem again is that you guys don't send actual example of what the problem is, or like what exactly the problem is. Yeah, you are submitting all the 4 tasks. I think we requested that you submit 4 out of everything, right? Yeah, 4 submissions. But I think in your case, you guys can just do 3. You can just do 3 because you don't have big teams to solve 4 tasks. Okay, about importing data. Let's see if I can get connected quickly. Sorry, I'm also working on a PhD project. Let me look for... okay, then I stop sharing. So let's say I want to import something. What can I import? Okay, I will import data set from our training. Let's reduce my screen. So let's assume I want to import with R for first, right? I'll do with Python as well. Let me pick any of the data sets. Okay, let's work on this. Or is there a preferred data set you want me to work on? Hello? Okay, I'll just pick one. I mean, I'll just work on RNA-seq. I don't know which one is giving you guys problem, but I can, first of all, what I always do before I import any data set is to ensure that the data is even present. Does it exist at all? So I copy the link and I'm pasting it here. So this is the data set. The data set actually exists, right? It's a lot of things, but yeah, it exists. So first of all, in R, I would see my sample name. Let's just say sample data link. Data link equals to this. Then, if I want to read, I can just simply say data sets is equals to read dot. I can use read dot delim because this is R. Okay, and I will say data link, and I would say I want to look at the first 5 things data sets in my data sets, and I'll run the code. Okay. That's what you guys say. Yeah, and I run the code. But it looks like if you notice, it's just one thing. It's just merging everything together. It's not separating them as individual columns. So I can change this to read the table. Can you guys see my screen?
No, it's
Oh,
like it froze or
okay.
something.
I'll stop sharing and then I'll share again. Can you see my screen?
Yes, sir.
And nobody was talking. Wow. Anyways, I'll go over it again. So first of all, I said the first thing I do is I copy the link and I check if the link itself exists. So in this case, it exists, right? I have my gene, my log two-fold change, my p-value, my p-adjusted value, and da 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 da. It's a very long data set, but yeah, it exists. Next, I save this link as a variable in R. Then I read dot, first of all, I did read dot delim because I just like this one. It works mostly for me. But in this case, it's not working. If you notice, it's stacking everything together as one column name. And then everything is not properly arranged. If it is properly arranged, you will see it. Okay. Then let's try to do read the table and then run the same code. You notice that it has changed, right? It is well arranged this time. But it's telling me that my column name is V1, V2, V3, and V4, which I don't want. I would say header equals to true. And I'll run it. And you realize that the actual column name becomes chain, log two-fold change, p-value, and p-adjusted value. Any questions? Because it's as simple as this. If read.delim does not work, use read.table if you're in R. It's not wow, it's just try it. What you guys mostly look for is one code that does everything. Unfortunately, you can't probably there are people from I think everybody here speaks English. You don't use one word most of the times. And sometimes the same one word can have two meanings. So it's also like that. Just always consider it as a language and you are speaking a language. Yeah. Okay. Let's try Python. So I'll save the same thing, data link, and I'll say, so instead of this, I'll use equal to, and I'll say, so I'll first of all import pandas. I'll just copy everything and I reload. Yeah. Import pandas as PD. Now I'll say PD dot read underscore, is it underscore read dot, no, underscore CSV. Yeah, read underscore CSV. I will remove this for the moment. And this is not these, I think it's dataset.head. And then I'll run it. Imports, hold on, I don't know what's wrong here. Sorry, not Python, not R. I changed it to Python and I will run it again. Oh yeah, sorry. I should print. Yeah. Yeah. I think it works. I'm just not sure. Hold on. I would try to confirm if it's picking the right columns. Yeah, okay. So it's also having an issue with identifying, hold on. It's having an issue with identifying the right column. So it's not importing properly, just like it's happened with R, right? But in Python, you don't have, sorry, so there's a biker around it. You don't have read.delim and read.table in Python. But what you can do is to specify the separator to be, let's look at the data again. I think it's how many spaces. So in this case, I just copy the spaces between the first two things. I think it's just a space, and then you run it. Yeah, you see? So basically what I did is I went to look for the number of space that is separating this, and I copied it and I pasted it here. I don't know if it looks like magic, but what's your comment? Any questions? Anyways, I would also say it's a little bit of experience. That's why I understand your points. But yeah, it's a little bit of experience from doing it severally. So you don't have to judge yourself so much. And from there, you can plot whatever you want to plot. Okay. Yeah, I hope I helped a little bit. Yeah, there's a recording. There's a recording. Okay, if there is no other question. Yeah, if there's no other question, then we close for the day. Then enjoy your hacking sessions. Bye, everybody.